Sorry. Now I'm just fussing around with my. Oh, I know. Here it is. Here it is. Got it. There we go. There we go. There we go. Sounds better. How's that? Is that better? All right. Sorry. Okay. Little technical difficulties. So what we're going to do is we're going to talk about the ones and the tens and the hundreds. So this is that's what it was because it was my wrong mic. Thank you guys so much. Thank you. Thank you. So what we're doing is we're talking about this. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. When we look, this is 10. So we have this. This is 11. So when we look at it, we have 1 and 1. So that's 11. And now we have 12. When we look, I'm going to rewrite it, and this is 12. So we have 12. That's not 12. This is 12. This is 12. This is 13, 14, and then 15. Now what we're going to do is we're going to continue on. So if you notice, this is the same, but the difference is the place values. So what's going to happen is this is 1, this is 10, 100, 1,000, and 10,000. Anybody have any questions? Let me know. So what we're going to do is we're going to continue on how to read the abacus. When we read the abacus and I see that we have 600 kj, 600 is this, 600. If there's anybody, welcome back, Ethan. Thank you so much. Welcome, welcome, welcome. I wonder if Beal is here. Okay, so this is 600. 600. That's what 600 is. That's one of the numbers that I see. So what other numbers do I see? I see 2136. 2136. So I'm going to add 2,136. Does that make sense? So let me know in the comments. Let me know in the comments if you have any questions. But I have 2,136. And so what we're doing is we are, hey, Beal, you're following. I have a question. What is the difference between the 2 beads on the top and the 1 bead? Oh, that's a beautiful question, love. Let me show you. So the difference is I have the Chinese abacus and the Japanese abacus. The Chinese abacus is the one with the 2 beads. So this is 2 beads, and then there's 5 beads on the bottom. 1, 2, 3, 4, 5. And then on the Japanese abacus, there's only 1 bead on top and 4 beads on the bottom. Now, the difference is that the Chinese abacus is a little redundant. So love, when we count it, we do 1, 2, 3, 4, 5. But now, since this is 5, we're going to have to trade it. This will be 5. We have to trade these beads into making a 5. But on the Japanese abacus, we do 1, 2, 3, 4, and then we have 5. Do you see the difference? So in the Japanese abacus, what we do is in the Japanese abacus, it's more efficient because that's what Japanese people do. They make everything more efficient. So when we look at it and we continue on, we do 6. We do 6. It's the same, right? But now on the Chinese abacus, we do 6, 7, 8, 9, 10. Hey, look at that. Someone who's new. For someone who's new, what would you recommend me learning first? I would recommend learning the Japanese abacus because the Japanese abacus is the more modern one. The Japanese abacus is the newest thing. So the Soroban, yeah. So the Soroban is the Japanese one. And I would tell you to do that one because it's very difficult to find a Chinese abacus nowadays. And if you want to do competition, there is Soroban competition. There's a bunch of Soroban competitions, but I would recommend doing this one first. And if it's for you, I would recommend. And I'm assuming that you're old, not like a child, not like if you're 5. But what I'm assuming is that you're older than not older than dirt, but if you're a little bit older, I would recommend getting a 13 column abacus. The reason why is because you can do more digits, right? Size matters. So for this one, this is a 7 column one, and you can do limited numbers. You can only, so because I have my dot indicator here, this will be my ones. So my ones, tens, hundred thousands, 10,000. I only have 1, 2, 3, 4, 5, 5 digits. So if you were to do multiplication, you're going to run out of room. Whereas on the 13 column one, you can do more. Is there a Chinese abacus competition? I don't think there is a Chinese abacus competition. I don't think that there is a organization for the Chinese abacus. There is an organization for the Japanese abacus, which is really interesting. But there is not one. Would you recommend the smaller one or the big one? Well, who is this for, love? Just so I can understand where you're coming from, because I mean, it just depends on who's trying to use it, and I'll tell you the reasons why. Um, for the young ones, hey, Bapple, welcome back. Welcome back. Yeah, I'm trying something really new. Would you recommend the bigger one or the smaller one? Oh, right, love. My question is who's it for? Is it for a child, and how old, right? Or is it for you? The reason why is because for the younger kids, as I mentioned before, for the younger kids, they like the colorful one. Um, and also the numbers at a younger age is not that big. And then it depends on how many, yeah, it depends on how many numbers you're going to be mathing. Exactly. And it also depends on the age. Because if you start with the young one, like if you start with this one, then you can graduate them. Then they can graduate to a bigger one. And we all like to graduate to a bigger one. Hey, Andre! I like the colorful one. I like the colorful one too. But I do find it a little bit tiring after a while because when you do a lot of questions, I think it gets a little bit tiring. Can the yes, the kids can use a 13 column one. Yes, it is possible. If you don't have enough funds, if you don't have a lot of money, and you only want to get one, then I would recommend getting the 13 column one. It's for myself. I'm in first year college and it's something more I want something more with more digits. Yes. Then yeah, Lofty, I got my abacus in Daiso today. Yes, right? So it's available in Daiso if you have one close to you. I believe 13 column one is available. For your love, the other question is in college, I'm assuming that your questions will not be more than 13 columns. You could pony up for a 23 column one, but to me I feel like that this is overkill. I think by then um it really depends on how big your numbers will get. You can do a lot with the 23 column one, but I don't know if you're going to use it all. I was wondering if you recommend the 13 if there was a bigger one size, yeah. Yeah, there is a bigger one. It depends on what you're. I mean, if you're going to be tracking the national debt, then I would get the 23 column one. If you're not tracking the national debt, then I think the 13 one would be fine because you do multiplication and you can choose the indicator here. So if you notice, there's an indicator on this side. So you can have 13 columns, 13 digits, or you can have 13 or 12 decimals because then you can choose this to be your decimals. So it'd be here, and then all of these would be your decimals. So it really does depend on where your dot indicator, which dot indicator you use. But I do believe that the 13 column one would still suffice even though you're in college. Sorry. I was wondering if you recommend. Okay, thank you. Thank you, Ethan. There's no bigger sizes beads, only more columns. That's correct. I gasped so hard when you said the national debt. I'm with jokes. Thank you. Yeah, so that's yes, exactly. So Ethan is correct. There is no fatter ones. There the ones that I've seen, they're not fatter ones. There's only the amount of digits. That's really it. So, if anybody else has any questions, thank you so much for asking all these questions, love. So does that make sense? So are you talking about like the size of the beads? Is that what you're talking about as well? I'm not sure. I'm not sure if there's any other sizes except for these ones, really. Okay, cool. Yeah. Were you talking about the Chinese abacus beads? Oh, so that was the other thing. um, it all matters about the okay. So if anybody else has any questions, we're going to continue on learning how to read the abacus. So Andre, do you remember we're going to do 100, 1000, We do 1,303. And what we did is we utilized our dot indicator. So we have our ones, our tens, our hundreds, our thousands. And that's what we're doing. Ha 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 ha. Yeah. All right. So what's going to happen is we're all done with that. Is there anybody have any questions? What we can do is we can continue on with adding and subtracting. Whoa. Sorry. And I always play around with the camera. All right. So, anybody else have any other questions? Hello, everybody. Hello. Thank you so much for the hearts. Thank you so much for the hearts. I wanted to see what was going on. So let's count some more. We're going to count 1, 2, 3, 4. Now, all the beads, these beads touching the horizontal bar, they are considered counted. So when they're considered counted, this is 4. Now, notice that none of the beads, none of the other columns, these are columns. These are also considered digits, right? Columns and digits, place values. Ones, tens, hundred, thousands, 10,000. These are all 0. So when we want to do 5, it's always going to be the top bead. The top bead has a value of 5. Because the value of 5, we have 5, 6, 7, 8, 9. So this is 9, and then how do we do 10? 10 is our next column over. We have our ones and our tens, just as how we write. So exactly how we write is exactly how the abacus will read. So we have 10. When we have 10, we have a 1 and a 0. Now, when we do 1 and a 0, we can count by 20s. We can count by 10s. This is 20, 30, 40, and then 50. That's 50. This is 50 because we want to make sure that all the beads are not touching except for this one. This is 50. This is not 10. This is 55. Does that make sense? So what we're doing is we're mimicking the same way we write. So this is 55 because it's 2 top beads and it's a 5 and a 5 with the place value, right? So we have our 55, and then we have 60, 70, 80, 90, and then 100, right? And then we can count to hundreds, right? We can count hundreds. 100, 200, 300, 400, and then 500. So I'm going to rewrite it, and I'm going to show you what 500 looks like, just in case you don't know what 500 looks like when we write it. So that's how we write 500. It'll be 600, 700, 800, 900. If anybody has any questions, let me know. Let me know if you have any questions. I'm going to continue on, and we're going to do some adding and subtracting. So if you notice, we actually did some really beginning parts of adding and subtracting. What does that mean? Well, if you notice, when we talk about 8 or 9, when we talk about 8, right? When we talk about 8, we actually have 5, 6, 7, 8. 5 plus 3 is 8. That's simple. So what we can do is we can do 5 plus 2 is 7. So what did we just do? We just did simple addition. Simple addition just means whether or not we can add, whether or not we have beads, whether or not we have enough beads to add. So that means that if I did this, if I had 9 and I want to add 3, my question is do I have enough? No, I don't have enough. So now we actually have to go into formulas. So when we go into formulas, there are things that we need to do. But before we do that, let's talk some more about simple adding and subtracting. So again, when I do 2 and I want to say plus 6, all I got to do is add 6. 5, 6, and I bring it together at the same time. So then if I want to minus the 6, I just need to take it away. So notice anytime the beads, it all matters about the direction of the beads. So when I go towards the horizontal bar, this is adding. When I subtract the horizontal bar, that is minus. Anybody have any questions? Are we okay? We're okay? Okay, I'm going to keep going. So then again, my next one would be 7. 5, 6, 7. So I'm going to add 7 together. And then what do? I'm going to take away 8. To take away 8, I do 5, 6, 7, 8. I'm going to utilize my beads and I'm going to take it away like that. Do you need short nails to move the beads freely? No. I'm sure you could use like really long nails. I cut mine often because my nails are kind of brittle. But I believe you would just be utilizing your nails more. It'd be like this, right? Like chopsticks. And it'd be like this. So if I had chopsticks, I guess it'd be like that, right? I guess it'd be easier. So this would be like, yeah, right? So if I want to add, if I want to add six, I bring it together. If I want to take away six, I take it apart. Ah, Ethan. You're so silly. But yeah, I think it'd be possible to use, to utilize it. And then if I wanted to do minus two, I just take away two. Now I'm going to use chopsticks to work with my abacus. So we're going to use the chopsticks and learn how to use the abacus. I'm hoping people know how to use chopsticks. If you don't know how to use chopsticks, then we will figure that out. So now the question is what if I don't have enough beads? If I don't have enough beads, what do I do? So here's a question. I have, let's do 3. 3 plus 4. Let me see if I can find my numbers. If I have 3 plus 4. If I have 3 plus 4, now what we're going to do is we're going to talk about some, here it is. Right. Okay, this is what we're going to do. So in school, we're teaching children how to how to make a 5. Now, why do we need to know this? We need to know how to make a 5 because we're going to start utilizing this bead, this top bead right here. To utilize that top bead, we're going to learn how to make a 5. So one of the ways to learn how to make a 5, because I want to add a 4. The question is, if I wrote my question, I didn't write my question. My question is 3 plus 4. Now, we don't memorize our doubles. What we do memorize is how do we use the add-in. This add-in is very specific. So what's going to happen is I want to add 4. To add the 4, we need to understand how to utilize our beads because we don't have enough beads here. We don't have enough beads to add the 4. So what do? We need to learn how to make a 5. If I need to do 4, 4 plus 1 is equal to 5. We are teaching this in school, right? That makes sense. So what happens? Well, that's all they teach in school. That's it. They're done. But in Abacus, we're going to supercharge this. We're going to supercharge this because what's going to happen is we're going to make our numbers work for us because there is no freeloading numbers in my house. To make it work, right? What we're going to do is we're going to isolate this variable. This is the variable we're going to isolate. It sounds very familiar with algebra because if you look, algebra looks like this. And what we're going to do is we're going to isolate this x. When we isolate the x, what happens? We need to move this 1 to the other side of the equation. So that means I've got to make the 4 by itself, we need to subtract 1 from each side of the equation. So I'm going to minus the 1 on both sides of the equation. So if I look at my 4 and I do plus 5, I need to, this is not balanced, right? My abacus is not balanced. So what I'm going to do is I'm going to minus the 1. Does that make sense? So what does that mean? Well, now I can utilize it. I can make my 5 work. I'm going to plus the 5 and take away the 1. So now my answer is 7. Does that make sense? Let me know if you have any comments or questions. If you're understanding if you understand what Abacus is doing, let me know. All right. So, but that's what we're doing is we're understanding how to utilize the add-in. When we utilize the add-in, then we can be more versatile. What does that mean? Well, the next question is 2 plus 4. When we do 2, I want to add the 4. There's not enough beats to add the 4. What do? Well, I do this. I already know how to do it, right? Now I'm building, I'm strengthening, I'm practicing. Hey, I'm practicing and building. I'm memorizing this formula. To memorize the formula, what I need to do is I need to plus the 4. If I want to add the 4, because there's not enough beats to plus the 4, what do? I plus the 5 and I take away the 1. So my answer is 6. Does that make sense? Wow, thank you guys for the 4K likes. That's fantastic. Thank you guys so much. That's crazy. Okay. I'm like streaming everywhere now. I figured it out. I almost did. I almost did. You almost did? You almost did what? You almost did understand? Lizette? Oh, one more. Okay, cool. Fantastic. Okay, okay. Let's do this. Let's do this. Okay. Thank you, Lisette. I didn't know you were here because I have my regulars and I didn't know you were around. Okay, so here's the question. We're gonna do another one. Let's do. We did 3. We do 4. We'll do 4. Hi again, honey. How's it going? Welcome back. Welcome back. Okay. Sorry. Okay. So what we're gonna do 4 plus 4. So we have 4. We do 4, and then we add another 4. Now notice we don't have enough beads to add a 4. And I was like, what? There's no beads to add the 4. Welcome, 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 Javi. Okay, so Lizette. Yes, Lizette. Okay, what we're going to do is we're going to add the 4. So we add the 4, and we don't have enough beads. We don't have enough beads to add the 4. What do? We don't memorize our doubles. That is a big no-no. What we do is we understand this. We want to plus the 5, and I take away the 1. So my answer is 8. Does that make sense? I'm looking for, yes, this is what I'm looking for. Yes. Okay. So let's do another one. We can do another one. Let's do another one. I got to get paper now. Cuz I don't have room. Okay. So there we are. We'll do another one. Let's do another one. Are we ready for another one? Okay. So if I did, thank you so much for the Galaxy Beal. Oh, I'm so new. 1, 2, so it's 1, 2, 3, 4, and then 5. Oh, right. Lizette. Yes. When we're counting, thank you so much for the Galaxy Beal. So when we're counting, it's 1, 2, 3, 4. But this is not a base 5 base. This is actually a 10 base. So we do 5, and then we do 6, 7, 8, and 9. So now we have 9, and then we do 10. Thank you so much, Lizette, for commenting. Because if I don't know you're around, I'm not gonna be able to explain it. So what happens is I'm trying to find my place values. So place values. Here we are. We're back to place values. So what's going to happen is we do ones. Why do we pick this one? I pick this one like Pokemon. I choose this one because I want this one to be my dot indicator. Yeah? So it makes sense, right? Ones, tens, hundreds, thousands, 10,000. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is 10. So after 10, hello, Olivia. So after 10, we do 11, and then 12, and then 13. Great! Fantastic! That makes sense, right? Simple to use, easy to understand. Ah, this is awesome. Yeah, okay, great. So what we just did is, the first thing we need to do is understand. I'm so confused, Teresa. No, don't be confused, Teresa. Let's do it again. So we count 1, 2, 3, 4, right? Just as we write it, 4. Anytime the beads are touching the horizontal bar, this is considered 4. So this is 4. Anytime it's a 5, it will always be the top bead. The top bead is always 5. 5, 6, 7, 8, and then 9. Does that make sense, Teresa? So, thank you, Beal, for the rose. So then we do 10. How do I know? Just like how we write. That is 10. We write as we read. Oh, yeah. So then let's do this. What would that look like? Well, that's a 50. 50 and a 0. 5 and a 0. Why? Because this is my tens. 5, 0. Tens. 5, 0. Whoa, 0. So then if I did this would be 5, 5, 5, 5, 5.5. So it would be 5, 5, 5, 5.55. Why? Because the decimal sits between the ones and the tenths. The reason why, right, just like our decimal sits, it doesn't sit on a place value. It sits between the two, the ones and the tenths. So the question goes into what happens when there's not enough beads. When we first start off, you'll notice that when we do 8, it's 5 and 3. 5 plus 3 is 8. The question is, do you have enough beads? Yes, you do have enough beads. So 5 plus 3 is 8. What if I did 3 plus 6? All I got to do is add the 6. Do I have enough? Yeah. 5, 6, and I add it together, and that's 6. So the question is always, do you have enough beads, right? So let's do minus. So we have 9 minus 3. We take away 3 just means I'm going to move it away from the horizontal bar. The horizontal bar is what tracks us. If you go towards it, that would be adding. If you go away from it, that's subtracting. Does that make sense? So what's going to happen is when there's, yes, exactly, Lizette, this is right. It is the number 6. Fantastic. Makes sense. So what's going to happen is if we look at it, right? It's always about do we have enough? Now the question is when you first came on board, the question is what happens when you don't have enough? If I have 3 and my question is 3 plus 4. Can you see that? 3 plus 4. 3 and I want to add the 4. Well, how do I add the 4? I can't add the 4. I don't have enough beads to add the 4. So what's going to happen? Well, remember in school, we're teaching children how to plus the 4 and 5. So, or plus 1 and 4. So we're going to do it this way, right? But this is not what we're going to do. What we're going to do, hey, Trey, hello. So what's going to happen is we need to utilize this concept. 1 plus 4 is 5, or 4 plus 5 is 1. We got to know this concept. What do we do with this concept? Well, this is where we make sure that we don't have freeloading numbers. So what happens is if we have if we have the number, right? This is the formula, not formula. This is the addition sentence. 4 plus 1 is equal to 5. We're going to supercharge this and it looks like algebra. So we subtract 1. Exactly. But we have to add the 5. We have to make sure we add the 5. So when we look at it, we want to add the 5. Adding the 5 is too much. We need to subtract the 1. So then my answer is 7. Does that make sense, Lizette? Right? So that was 3. So we can do 2, right? The reason why is because now it's more versatile, right? We don't memorize our doubles. We don't be like 4 plus 4 is 8. Yeah. No, we don't do that. We do 4 plus what 4 is plus the 5 minus the 1. Yeah. That's what it is. So what's going to happen is, let's say the reason why is, let's say we did 3 plus 4. We don't do doubles, 4 plus 4 minus 1. We don't do that strategy. What we do is this formula. This is a fundamental formula that we're going to build on. So we need to plus the 5 minus the 1. That's all we're doing. And this is the thing that we remember all the time. Plus the 5 minus the 1. Woo, woo. Plus the 5 minus the 1. Yay. Right? It's a chant. So when you see it, okay, so now here's the thing. We know how to add. What do we do when we subtract? With the doubles, right? When we do 4 plus 4 is equal to 8. With the doubles, there's no such thing as double minus. So what does that mean? Well, in Abacus, we can do subtraction. It's the same thing, but reverse the operators. So what we're going to do is minus the 4. If I want to take away the 4, what do? I minus the 5 and I plus the 1. Why would I want to do that? Well, if I have 7, right, and I need to take away 4. Well, look, I already know. Now I just got to, build on it. So all I got to do is minus the 5 and add the 1. My answer is 3. Does that make sense? Okay, good. We'll do more than just one. But instead of doing 4, right, Trey? Good. You understand? So what we're going to do is we're going to do a little bit more. Why? Because there's a whole family here. what's going to happen is instead of doing a 4, instead of adding a 4, we could do the same thing with a 3. We can do the same thing with a 3. Let me just rearrange this. We can do the same thing with a 3. So what does that mean? Well, we know, how do we make a 5? We do 3 plus 2 equals to 5. There's a whole set. So notice we focus on the add-in. We only focus this number here. We don't focus on the result. We focus on the add-in. So what's going to happen is we have 3 plus 2 is equal to 5. 3 plus 2 is equal to 5. We need to isolate the variable. We're going to look for the 3. So we're going to take this 2 and we're going to move it over there. So to make the 3 by itself, we're going to need to subtract the 2. So what's going to happen is, let me rewrite it. If I say plus 3 is equal to plus 5, is this balanced? No. Thank you, Lizette. Yes, we need to minus the 2. Excuse me. So let's look at our question. Let's do 4. Let's do 4 plus 3. We know the answer is 7, right? But how do we get there? It's not about the result. It's about the process. It's about the journey, right? So Abacus mimics life. So here we do 4. We do 4, right? There's my 4. I'm going to add 3. There's not enough to add 3. Because there's not enough to add 3, what do? I need to plus the 5 and take away the 2. Does that make sense? Yes, right? It's really quite cool. It's really quite cool. Oh, thank you so much for liking the live. Wow, 5,000 likes. Thank you guys. Does that make sense? So when do we use it? We use it whenever we're doing arithmetic. We're doing adding, subtraction, multiplication, division. But the first thing we need to do is understand how to add. After we learn how to add, we have to do subtraction. After we have subtract, then we can do multiplication. So, okay, let's take it one step further. We know how to we know how to add the 3. We now know how to minus the 3. So minus the 3 equals to minus the 5 plus the 2. So let's do a question. Let's do the question 17 minus 3. What? 17 minus 3? Hold on. We're okay, right? Let's do 17. And then when we minus the 3, we're right here. We're only looking at the one column. We want to minus the 3. How do we minus the 3? Can we take away 3? No, we can't take away the 3. What do? We have to minus the 5 plus the 2. So we're going to minus the 5 and we add the 2. So my answer is 14. Make sense? Yeah. It's really quite cool when people get it. And I'm like, oh my God, this is the greatest thing next to sliced bread. It sure is. It's as great as Betty White. Trey, you all right? Okay, good. You're still here. Right? Does that make sense? So what it is we're learning. That one was a bit fast. Ah, okay. That's all right. We'll do it again. Okay. So I was trying to make 17 first. Yep. We're trying to do 17. 17. 1, 7. 5, 6, 7. That's 7. Yep, you're right. But see, the thing is we don't look at anything else except for the one column. We don't look at 2 columns. We only look at 1 column. Does that make sense? We're trying to take away 3 from the 7. Minus 3. So what are we going to do? Minus the 3. Minus 3 is equal to minus 5 plus 2. So then Yay, Kaylee! What's going on? Welcome back. Oh yeah. It's funny. I was talking to a friend of mine. I was talking to Audrey. I don't know if you remember Audrey, but I was talking to Audrey and how like men and boys are like, "What's up? How's it going?" But women are like, "Oh my god," and girls are like, "Oh my god, yeah, welcome back! I'm so excited." Anyways, um, so what's gonna happen is we're not need to minus the 3. Don't look at the 1. You look at the 7. So can I take away 3 from the 7? No, I can't take away 3 from the 7. What do? I have to minus the 5 and then plus the 2. So I'm going to minus the 5 and I'm plus the 2. So then, guys are so chill for no reason. Right, Sai? I don't know why. But like my kid went to a practice and he saw some old friends and all they said was, "Sup?" And they had the head nod too. "Sup?" So, does that make sense, Lizette? So we do 14. Our answer is 14. When we look at it, we want to make sure we look at the one column. Don't look at too many columns. So Abacus breaks it down into manageable chunks. Because Abacus breaks it down into manageable chunks, we don't want to get overwhelmed. When we don't get overwhelmed, then we can focus on what we're trying to do, which is I'm trying to find my cap to my trying to find my cap. Here it is. Yeah? Does that make sense? So, yeah, I'm trying something new. Da, da, da. Okay, if anybody has any questions, but yeah, ha ha, this is great. I'm streaming on like so many platforms. Okay, this is fantastic. I have Instagram over here. I have Facebook and YouTube on this side, and we're just seeing. Okay, so I'm kind of lost at minus the 2 plus the 5. Oh, okay. So do we understand how to minus the 3? So let's take it one step further. Um, so we do minus the 5. So, oh, you know what? Here, this is what I do sometimes. We're going to do is we're going to subtract the 3. Why are we going to do that? Well, we need to subtract the 3. Try to think of it this way, where we do minus 3 minus 2 equals minus 5. Does that make sense? Why? Because we got to keep the minus. And what we're doing is we are subtracting the 3. So when we subtract the 3, we got to keep everything minus, and we got to make sure that they're minus 5. Does that make sense? So when we move the 2 over, we're isolating this variable. When we isolate this variable, we need to move that to be a plus. So if I do this, 3 equals minus 5, notice this is not balanced. To balance this equation, we need to add the 2. Does that make sense? Hey, Geek Bar. Welcome. Thank you for the follow. Yeah, okay. So now, when we do piscusi, I don't know if I'm gonna say that. So now, let's do not we'll do 7. We'll do 7 instead. So instead of doing 17, we'll do 7. 7 minus 3. Can we take away 3? Notice I only have 2 beads here. I cannot take away 3, so I have to utilize the formula. I need to minus the 5, so I'm going to take away the 5, which means I'm going to move it up, and I'm going to add 2. 1, 2. These are the 2 beads I'm going to add, and that's what I'm going to do. So that, and then that becomes 4. Does that make sense? Thank you for the follow, Sonia. Haha, thank you, Geek Bar, for the like. Wow, I'm at 5,000. Woo! Does that make sense? So if you look, this is what I'm doing. I understand, but I don't understand. I understand, but I don't understand. Because we're trying to subtract. It's not a negative. What we want to do is we want to do a takeaway. Let me see. Let me think about that. I have to marinate on it. We can do a couple more. Because what happens is, I mean, we did the 4, but you understood the 4. um, it's kind of the same concept. It's just now we're doing 3. So we did the 4, and it's the same thing. Oh, okay. The 3, if you notice, when we add 4, and we don't want to do a 3, we want to add the 3. It's plus the 5, take away the 2. So when we look at it, this is the number pattern. So now we just do the opposite. The opposite of the number pattern is like that. So when we add the 3, I'm going to plus the 5, take away the 2. When I minus the 3, I need to minus the 5 and add the 2. So this is a number pattern you're going to start seeing more and more. I mean, depending on how often you do Abacus. So when you see it, so when I do 4, let's say we have 7, take away 4 is minus the 5 plus the 1. I'm only moving these 2 beads. So if you notice, I can do, if you notice, when I add the 4, I can do plus the 5 minus the 1, or I could say minus the 1 plus the 5. Hey, Knock, thank you for the like. So this is exactly the same. This doesn't matter. The way this works, it doesn't matter. So if you look, this is plus 4 minus 1 plus 5, or we do minus the 4 is equal to minus the 5 plus the 1. It's the same. These two are just the inverse. Does that make sense? So this is the plus 4, and then the other one is a minus 4. Yeah. Okay. So then it's the same thing with this one. This is another one. So we have our adding, which is 3 plus 2 equals to 5. But then we'd have to do the minus sign, right? So the minus is minus the 2 minus the 3 equals to minus the 5. Yeah, that makes sense. Really? Okay. That's good. So, I mean, well, let's take it one step further. Let's do a 2. We'll do it 2. You know what? Okay, fine. We'll do it 2. We'll see, right? So it's the 2 is the same thing. But the difference is instead of doing a 3, we're doing a 2. They're pairs. So 2 plus 3 equals to 5. When we isolate this variable, we need to move the 3 over here. So it's 2 equals to 5. No, this is too much. So we need to minus the 3. Now this is balanced. It's the same thing when we subtract. Subtract 2 minus 3 equals to minus the 5. Yes, thank you, Trey Trey. Yes. So when we do it and we do the inverse, it's this way, right? Minus 2 equals minus 5 plus 3. And then this is the formula that we need to use. When we're looking for a minus 2, when we want to take away the 2, 6, take away 2. There's not enough beats to take away the 2. So what do? I have to minus the 5 plus the 3. Minus the 5 and then add the 3. So my answer is 4. So this is about building fundamentals. And now I just got my, oh, yay! Oh, so good, Ruben. That's fantastic. So what we're doing here is we're learning the basics. I see the pattern. Yeah. The biggest thing is to see the pattern. And it's obviously it's harder because this is video. If you had it with you, you could see it's a lot easier to see if you actually had the abacus. I have to order one. So, but to understand the pattern, you will notice that there's a pattern. But I need to try to exaggerate it a little bit because it's on video. So again, this is the number pattern. Now, when we look at the number pattern, we have 6. Oh, what I'm trying to say is this is simple. This is easy to understand. That's not the problem. The what it is it actually scales to larger numbers. We just don't know it, right? So we can make a huge number like I just did 17, right? It translates to larger numbers. So even if I did like I don't know, 4,326, right? I want to add the 2 here. I'll add the 2 here. And then this will be 1, 1, 2, right? So here, I'm going to do 4,000. So I'll do 4,326. So I'm going to add 2. Remember how to add the 2. To add the 2, I need to plus the 5 minus the 3. Because look, I don't have enough beads to plus the 5. I don't have enough beads to add the 2. So focus on the column. How do I add the 2? Cannot. I have to plus the 5 minus the 3. So I plus the 5, take away the 3. And then I go to my next number, go to my next column. I add the 1, I add another 1, and then I add the 2. So, I mean, this is a 4-digit number, but notice I only needed to use the abacus. I only need to use the formula once. So it all depends about the add-in. It all depends about what you're trying to do, what you're trying to accomplish. Does that make sense? So, yeah. So the thing is, the reason why we do this is so that we can scale to larger numbers. That's why. This is really easy. This is super easy. Yes, I understand. It's really easy. But when we understand the basics and the fundamentals, then we can translate it to bigger numbers. That's great, Lizette. Good. Does that make okay, good. So that is how to make a 5. Well, what's after that? After that, does this become muscle memory once you've doing it for a while? Yes, it does for the most part. Some people kind of argue against it. It is for the most part. But I think for me visually, I see it more than I do muscle memory. So like for me, when I do plus the 4, I know I'm going to do this because in my head, I know I don't have enough beats to add the 4. I know I'm going to do this. So for me, it's very visual. I don't know if that makes sense. MLB, not baseball. So, okay. So we understand how to make a 5. Well, guess what we're going to do now? We're going to have to figure out how to make a 10. Now, oh yeah. Yeah. It's a very visual. I think it's very visual. I don't know why we're trying to push the kids to do mental math. I don't understand why. Even still using the abacus to see the numbers, I think it makes more sense. Like you could do multiplication division on him. So, yeah. Yeah, see, I think for me I'm very visual so I could see it. So that's why I try to exaggerate the movement. So when we do so what we're going to do is we're going to add a 10. We're going to make a 10. What does that mean, make a 10? Well, I was trying to talk about like the whole grouping and regrouping. In abacus, not in abacus, in mainstream math, we talk about grouping, regrouping, carrying on, trading, borrowing. We do all these things. But in abacus, the only thing we need to worry about is how to make a 10 and how to take away the 10. That's all it. That's it. We just need to learn how to add a 10 and take away the 10. That's all we need to do. What does that mean? Well, the first thing we do, right? The first thing we do is understand how to make a 10. I'm going to show you how to make a 10. And that's what I did. The first thing we're going to do is how to make a 10. How to make a 10 with a 9. To do that, we do 1 plus 9. 9 plus 1 is equal to 10. Easy, right? It is easy. It is so easy. It's so easy, it baffles my mind how easy it is. Again, what are we going to do? We're going to isolate the variable. What are we trying to find? We are trying to find a 9. That's all we're doing. So what we're doing is this one. We'll do this one. Plus 4, 4 plus 9. That's it, 4 plus 9. Okay, what happens? 4 plus 9. Well, the first thing we need to do is we need to isolate the variable. Sometimes I mumble and I apologize and I know I talk fast. Let me know if it makes sense. If it doesn't, we will keep going until it makes sense. So we're going to isolate the variable. This is the variable we're going to isolate. What does that mean? We got to take this 1 to the other side of the equation. So when I look at it, I'm going to do 9 is equal to 10. That's too much. This is not a balanced equation. This is 6, 7. This is a 9, 10. No, I don't know. So right here, to make it balanced, what do? We have to minus the 1. This is the formula. This is the formula that we need to memorize. what's going to happen is we're going to substitute this information to the 9. So when I look at it, 4 minus 9, I'm sorry, 4 plus 9, I'm going to plus the 10, take away the 1. What? What does that mean? So what's going to happen is I want to add the 4. There's not enough beads to add the 4. What do? I need to plus the 10. Plussing the 10 only means go to the next column. That's it. You're not going to go all the way over here. You're only going to go to the next column over. You're only going to go to the neighbor and say, hey, do you have any sugar? I don't know if you do that anymore. What do I do with my neighbor? I talk to my neighbor and say, hey, I see that you have an orange tree. Can I have some oranges? That's what I would do. I don't ask for sugar from my neighbor. I ask for oranges. So what I'll do is I go to my neighbor and say, hey, neighbor, how's it going? And I add my 10. And then I'll be like, okay, let's do an exchange. And I'm going to take away the 1. So my answer is 13. Does that make sense? We can do another one. Yeah, cool. We're doing another one. So let's do 9, right? The question is 9. So I have my 9. I'm sorry, 3. I'm going to add 3. I don't have enough beads I don't have enough beads to add the 9. See, I only have 6, 5 and 6. I only don't have enough beads. So what do? I want to add the 9. To add the 9, what do? Well, this one, I decided to go to the asteroid belt. So I need to go to the asteroid belt, which means I got to go to the 10. That's it. I just got to go here, no matter where. I was trying to do it on my own, but I confused myself. But then you unconfused me. That's great. So here, I just need to add the 10. Notice I need to plus the 10 minus the 1. Plus the 10 minus the 1. I got to go to the asteroid belt. This is the asteroid belt. So I go to the 10. That's the asteroid belt. And I count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I need to take away the 1. So I got to take away 1. And now my answer is 12. Easy? Easy peasy, lemon squeezy. Right. Right? I'm telling you. But see, look, there's a number pattern. When I want to add the 9, it's always going to be a plus the 10 minus the 1. That will always be the case. And then the other way, right? If I want to minus the 9, I have to minus the 10 and add the 1. So now we're in another pattern. When we see the pattern, it becomes easier. I love being able to follow along. Now. That's so funny. You guys. You guys are so awesome. You guys are really awesome. Thank you guys so much. Oh, Javi, thank you for the heart me. Does that make sense, Lizette? No, you're ha ha ha, Beal. I just it warms my heart that I found people that really enjoy Abacus. Yes, a lot of it. Okay, good. So that's the 9. What are we going to do? We're going to do the minus sign. Can we do minus? Do you want to do minus? We're just going to practice. We're going to practice how to take it away. But I don't have any. Okay. So I gotta erase so I can come back to it. Okay. So, whoa, that is not an earthquake. All right. So what are we going to do? We can do the same thing. I looked forward to. Oh, you did. I was trying to work on my book. Thank you, Javi. I wasn't sure. Okay. So here's a sample question. I have 10. Do you see that I have 10 here? 1 and a 0. So it's a 1 and a 0. My question is to minus the 9. I don't have any beads to take away the 9. I don't have any beads to take away the 9. So what do? I have to minus the 9. Well, remember, we do minus 9 minus 1 equals to minus 10. Do you remember that? It looks very familiar, doesn't it? So that's what it is. Because it looks very familiar, we can build on this strategy. My whole life I wanted to learn, but I was unable to. Now I can, and you make it easy. Ah, yeah. Yeah, you take one and you add one. Exactly. Exactly. So let's isolate the variable. We're going to move this over to here. We're going to minus the 9 equals to minus the 10, and then plus the 1. And you're right, Lizette. We're going to take one and we're going to add one. And that's it. Easy. Thank you, Beal. That's so interesting. That's so interesting. I do know that the videos on YouTube is really confusing, but it does help to be live, to have this conversation, to be able to have feedback. So that's 9. No, we're going to take away the 9. So we're taking away the 9. So my answer is 1. So that's taking away the 9. There's more, right? What else is there? Well, there's the 8, right? 8 and 7 and then 6. So we can do 8. So 8's the same thing. But now what's the oh yeah, minus the yeah. So we can do 8, right? 8 plus 2 equals to 10. There's a whole formula. Wait. I see this and I wish I'd been taught in school. It's very interesting. Yeah, I wish it was taught in school too. No. The question is 10 minus 9. That's the question. So what we're going to do is we're going to take away the 9. Minus the 9 equals to minus the 10 plus the 1. That's what that means. Yeah. It gets a little confusing. Maybe I should change this. Maybe I should change this then instead. Make it, I don't know, 18. Or 11. I can make it 11. Yeah. Maybe I'll make it 11 and then it won't be so confusing. But this was just a sample question. Yeah. Yeah, Trey. Well, yeah. I mean, I didn't learn this when I was a kid. I learned it when I was old. My kids learned it when they were kids. And I live vicariously through my children. And they appreciate it. They understand it. But they hated it during the process. Oh, it was such a painful process. Okay, so there's a question. Javi, can you get the answers in negative numbers? No. No. You could do 2 minus 6, but the thing is you would have to keep the minus sign in your head. So even still, it'd be 6. I would still have to do 2 because you can't do negative. You can't do a negative of a concrete thing. I bet math got easier when they understood it. Yeah, math got really easy for them. Like my one kid, he went to learning algebra and he's like, I don't know algebra, but I know algebra. Because we have algebra concepts. We isolated the variable, we moved it over, right? We isolated the variable, then we did substitution. So that's what substitution is, right? We do little things that's algebraic. So, Javi, did that make sense? You can't take a negative number of a concrete thing. So if you look at the abacus itself, it's always going to be positive no matter what. You can do decimals, but yeah, we can't do negatives. Yeah, I think algebra should use this. And you know what? Abacus is the gateway to complex math. Abacus provides the beginnings of algebra, if that makes sense. Thank you for the rose, Javi. But what happens is abacus is not the end all. Abacus just lays down the foundation, the groundwork. Because abacus lays the foundation, the groundwork, it's easier to do more complex math because you have more of a solid understanding of your numbers. It's like number fluency, number flexibility, number, I don't know. There's a whole bunch of number terminologies that's out there. But the biggest thing is to understand how to work the numbers. And so abacus helps to visualize what's going on. So like for this one, like 8 plus 2, right? Same thing. 8 plus 2, we're going to isolate the variable. Again, we've done this before. So now we have a pattern. It helps to understand the visual learners. Yeah. You know what? It's also very tactile as well. And so, they talk about being tactile. I do a lot of voice, and like I say it out things out loud a lot because some people are audio learners. So that's why I repeat a lot and I talk about it. And so hopefully those people that are audio learners can also pick it up as well as see it and feel it. So there's three inputs that comes through the brain, right? They can see it, right? They see it. I want to do 8, and then I'm going to plus the 2, right? they could see it, they could touch it, and they could hear it. So I think that's why Abacus is so good, because we don't focus on the abstract. This is, if you think about it, the numbers themselves are very abstract. So here we're going to isolate their variable. To isolate the variable, again, we've seen this pattern before. All we got to do is move it over to the other side. We have 8 equals to plus the 10 minus the 2. This is a pattern. So again, we see the pattern and we just mimic it. You've convinced me of getting... Welcome to the real world. Has somebody taken the blue pill or the red pill? Same here. I'm going to give this try to my nieces. Yes. How old are your nieces, Trey? Just so I can understand. Because it also depends on like how old they are. Yeah, the blue pill. I love the Matrix. I love the Matrix. Welcome to the real world. Okay. Yeah, how old are your nieces, if it's okay for me to ask? 6 and 7. 6 and 7. Yeah, they would really enjoy the colorful beads. And then what they can do is when they get older, if you choose to graduate them, you can take them to the um to the uh to the other one. Or you can just get this one and be boring. It's up to you. I used this one for a very long time. Not this one specifically. I've used, so this is mine. This is mine, and this is 23 columns. And this is made out of bamboo, and it's straight from Japan. But now the new ones that you see are plastic, and they may or may not be from China. But then I don't know what kind of tariffs there'll be. I'm sure it'll be a little bit. Oh my god, you scared me a little. Well, no, this one is just about how big your numbers will get. That's all it is. So it's like tracking the national debt, right? It's going to be in the trillions. So that's what this is. That's all it is. It works exactly the same. We can do it here. We can do the 9 and then want to add another 9. Oh, sorry. I want to add another 9. So I'm going to do 9. I want to add another 9. To add another 9, I just need to plus the 10, take away the 1. Plus the 10, take away the 1. It's all the same. It doesn't matter, right? It just matters how big your numbers get. If you think you're going to be using a large number, then you can, but usually we don't work with big numbers, because by the time we work with big numbers, we're starting to use calculators, right? So it all depends on what we're trying to do. I do this to keep my mind active. It's like that. This is the big. This is the longest one I have. 23 columns. I don't have any others. But it's about brain gymnastics, right? Why do we do crossword puzzles? Why do we do Sudoku? Why do we do word searches? It's the same thing. I mean, like, do I need to teach my kids? No, because they're old. Hopefully what can happen is that they will utilize it later. And when they have kids, they're going to teach their kids, right? The idea is to carry it on and have them understand, but they know how to do it, if that makes sense. But yeah, going back, like, the only time that my kids need to do the abacus is when they have to do adding, subtraction, multiplication, division without the calculator. That was one of the reasons I wanted to exercise. Yeah, get some brain exercises. And that's the thing. And it's fantastic. I think it's the greatest thing because if you notice, we're just using the numbers to track it. We're just using the abacus to track the numbers. If you look at it, there is no automatic there's no automatic happening here. What happens is we have to think about what we're trying to do. So when we had our question, right, 9 plus 9, this is something that we have in our brain. We are the calculator. Somebody said that. I believe it was Ruben that said that, right? We are the calculator, right? We want to know, how do I add the 10 here? Because I could see I don't have any more beads. What do I do? These are questions we have. In Abacus, we have conversations with our questions. We have conversations with our questions. We want to make sure we understand what we're trying to do. We're just not doing it just to do it, right? We're not doing it to just memorize strategies. We're doing it because we need to know what we're trying to do. Why do I need to when I have 4, why do I need to add? My question is to add the 9. Why do I need to add plus the 10 minus the 2, plus the 10 minus the 1? Why? Because I don't have enough beads. That's why. Let's say we did 8. 8 plus 4. Or no, 4 plus 8. The question is do I have enough? No, I don't have enough. What do I do? Well, I know plus 8 is equal to plus the 10 minus 2. So I'm going to plus the 10. Adding 10 only means go to the next column. That's it. Just like borrowing, carrying over, what else? Trading, regrouping, all that stuff. We're only talking about this 110. That's it. That's all we're talking about. Nothing else. Plus the 10, take away the 2. So my answer is 12. Does that make sense? So, and it gets deeper. It gets really deep because now we can start doing. So if we understand this, we can actually start going into a two-step equation. Two-step equation. What does that mean? Two-step equation. What's going to happen is if I don't have enough beads. So the first thing we're going to do is understand what our question is. So we have our one question. 7 plus 7. That would be easy. Again, we don't memorize our doubles. What are we going to do? We're going to add the 7. To add the 7, we know our formula. 7 plus 3 equals to 10. We need to know this. Okay, fine. I need to know it. I know it. I know it. 7 is equal to 10 minus 3. Thank you, Lizette. Yes, minus 3, right? Okay, okay. So this is our formula. We understand. So I have 7. I have 7. I'm going to plus the 10 minus 3. So, this is where cumulative. Okay, I'm going to 7 equals plus the 10 minus 3. Plus the 10 minus 3. I'm going to plus the 10. I take away the 3. What? I don't have enough beads to take away the 3. Now what do I do? Thank you, Beal, for the heart me. What do I do? What do I do? I need to take away 3. I can't take away 3. This now gets to be substituted. What do we do? Minus 3. We know this. Minus 3 equals minus 5 plus 2. We know this. See? Now we're building. Oh, yes. Thank you, Javi, right? We're building. We substitute this into here now. Yes, Lizette. So we minus the 5 and we add the 2. So my answer is 14. My answer is 14. So why is this a two-step equation? Because we had to do 1 and then we had to do 2. That's why it's a two-step equation. That is, this is the beginning parts of algebra because algebra has two-step equations, right? So what we do is we introduce, so this is where we become number flexible. Do you still have the long paper sheet that has all these formulas on it? Do I have the long paper? Like, oh, my little flippy thingy? This? Yeah, this is on my website right now. It's on my website and I updated it. It's on my website and so I updated it to be vertical. So what happens is if I want to, let's see this, I want to plus the 4. So I'm going to plus the 4 to 14. Plus the 4 to 14. What do? I know I need to plus the 5 minus the 1. If I line it up, I line it up. I'm not going to put a line here because I didn't want to make it fraction. But if I line it up, this says plus the 5 and then take away the 1. So my answer is 18. Yeah, Lofty. It's on my website. Did you try to buy it? Oh, yeah, there's a few pages. There's one that's vertical. So this is the vertical one. It's the same, but it's vertical. So this is vertical, and then this is the horizontal. So that's a vertical and horizontal. So I made it two different formats, and it's available. The links are restricted for those who aren't old enough. Oh, DM me and I'll send you my DM me, and then you can go to my website. Uh, if that's okay. Yeah, if you want to, you can DM me. It's learning. My website is learningwithlynette.com. Actually, you can just go to my website. Let's see if I have paper. So, learning with Lynette.com. If that's okay. You can just go there, and then you'll see there's an Abacus store. I think I called it Abacus store. If you're not old enough, I'm gonna hop off. Yeah, thank you, Ruben, for getting my son ready for bed. Yeah, not a problem. Thank you for reminding me of everything. Yeah, not a problem, not a problem. It's good to see you. Yeah, the kids should be in bed. It's so late. My kids are on spring break. So change the YN is my name. Yeah, yeah, exactly. My name is Lynette. But yeah, have a good night, Ruben. I'll see you in my next live. Hey, Mav. So does that make sense? Wow, there's still 14 people here. Whoa. Anybody have any questions? So what's gonna happen is what? So that's the two-step equation. So that's what the two-step equation is. So let's say, oh, finally, okay, great. Yeah. There should be at the top, it either says, yeah, look for the Abacus store. I just updated it. And so there's going to be a bunch of papers. So there's, one-sided, two-sided, and so forth. It's called flipping formula. um, yeah, it was just one of those things. This was it is yeah. Okay. So before I forget, so we're gonna continue on to the two-step equation. So let's do. You're amazing at teaching this. Oh, thank you so much. I appreciate that. I hope I am. I'm very happy I am. Thank you. I appreciate that. Yeah. Thank you. I appreciate that. So let's do another one. We'll do another two-step equation. What does that mean? Well, let's do 49 plus 7. We're going to do 7 because we remember 7, right? Should we do 7? We'll do 7. So what does that mean? We'll do 49. This is going to be different. Why? 49 and plus 9 is equal to 7. This is going to be a little bit of a doozy. Why? Because now we're going to add the 7. We know when we add the 7, it's plus the 10 minus the 3. Now look. Now we get into like some craziness. So what's going to happen is we want to plus the 10 and then minus the 3. Oh, we can minus the 3. So this, what? So this is called commutative property. What is it? So this 7 is equal to minus 3 plus 10. This is the same. So what we're going to do is we're going to take away, no, we're going to add. We're going to add 7 to this number. That's what we're going to do. We're going to add this number. So what does that mean? I'm going to plus the 7 is plus the 10 minus the 3. So I'm going to minus the 3 first because that's what I remember. I'm going to minus the 3. I'm going to add the 10. How am I going to add the 10? What's another way to add a 10? What's another way to plus the 1? Because remember, adding a 10 just means I'm going to go over. So then I have my new flippy thingy. So here's my little flippy thingy. I'm going to add a 10. I need to add a 10. So if I line it up, one green on the left. Exactly. No. Can't be. I don't have enough. Yes, Javi. Yes, Javi. So look, I don't have enough beads to add the 1. So what do? I need to plus the 1. Plus the 1. Then I get my little flippy thingy. What do? Plus the 5 and take away the 4. Did that make sense? So when I want to add the 1, I need to plus the 5, take away the 4. I do like this vertical one. So we already subtract the 3, right? And then we added the 1. 56. Yes. So did you see? So what we did is another two-step equation. But the two-step now was on this side. Smelly just joined. Welcome. So what we did is we have our different ways. So this is one way, this is one step two-step equation. This is another two-step equation, and then there's more. I mean, there's a lot more. It's just understanding. But if you look at it, you only needed to know how to make a 10 and how to make a 5. That is the only thing you need to know. That's what blew my mind when I was like thinking about it. That's what blew my mind. I was like, what? I only need to know these two sets of formulas. Because you know these two sets of formulas, everything can be added. It just depends on what you're trying to do. I suddenly have to go to sleep. Yeah, go to sleep. So much homework to do tomorrow. I'm sorry. Thank you for teaching me something new. Yeah, not a problem, Lisette. Welcome back. I'll see you in my next live. Yeah. Yeah, it's good, right? Makes sense? But yeah, that was the crazy thing. Like, you only need to know these sets of formulas. Ha ha ha. Hey, Steph. Have a good night, Lisette. And good luck on your homework. You need to do homework. Stop doom scrolling. All right. So anybody have any questions? Anybody have any questions? Are we all right? Thank you for the level up. Yeah, yeah. Anybody have any questions? Are we all right? Wow, there's still 10 people here, and I've got almost 7,000 likes on this live. All right. How are we doing? We all right? We want to go more? We want to do some more two-step equations? So that was the one thing, was to understand how to do two-step equations. Why is this a problem? It's not a problem. It's just solidifying. Okay, great. It's just solidifying what we're learning, right? So here's another one that. So let's do. We had one question. Well, you know what? We had this question. Hello. I've been doing mixed numbers and fractions with my son. Ooh, hey Steph. You know, mixed numbers and fractions with my son. That's, yeah. You would have to convert it if you wanted to do that in Abacus. You'd have to convert it into a fraction, and then a fraction is just a division. Good luck. Good luck, Steph. Okay. So this question. This is not a really two-step question, but it's interesting to see. So we have 100. Take away 9. Take away 9. What are we doing? Take away 99. This is easy, right? This is where we start talking about borrowing. Right? This is when we start to borrow. We want to minus the 9. So in minus the 9, what am I doing? Minus the 10 plus the 1. Minus the 10. But I'm going to do it here, right? So where's my other little contraption? I don't know. I had so many little contraptions. Oh, here it is. So when we're looking at it, we want to minus the 9. When we minus the 9, we're going to minus the 9 here. That's what we're trying to do. We're trying to take away the 9 from 0, but we can't. So what do? We have to minus the 10 and then plus the 1. That's what we're going to do. We're going to minus the 9. We have to minus the 10. So that means we got to go to the other side. That's all we're doing. Minus the 10 and then plus the 1. So then we have to minus the 9 again. When we minus the 9, we don't have enough. What do? Hi, Eve. Midnight math. You're right. You're right. It is midnight math. So what do? Minus the 9. We have to minus the 10 and plus the 1. Does that make sense, Trey? So we're going to minus the 10 and then plus the 1. And then when I take it up, my answer is 1. So this was just more repeating. Yeah. My abacus will be here tomorrow. Okay, cool. Oh, yeah, that's great. That's fantastic. That's exciting, Beal. That's really exciting. Does that make sense, Trey? Yeah. So, I mean, I don't even know how to, like, what do? When we do it in regular math, right? We do this first. So what do? We have to uh put the 10 here, cross this out, make this 9, cross this out, make this, right? That's what we do. Oh, sorry. So that's the borrowing and carrying over. But in Abacus, we don't do it that way. In Abacus, we do it left to right. So that's why we do this. We take away the 9. We don't look at everything. We just look at the one column that we're trying to take away the 9. So because we do 1, so then that's it. So now we have to try to take away a 9 again. So then it kind of falls into itself, right? It kind of makes a lot of sense when it happens. Yeah. So that's the one thing. So we just do it again. Minus the 9 is minus the 10 plus the 1. So, and it's interesting. But see, the thing is once you see the pattern, it's easy to move, right? The thing was, it kind of bothers me sometimes when people walk into the middle of my conversation and they're like, well, you're making it more complicated than it really is. I was like, wait, hold on. Hold on. But see, the thing is now we know the fundamentals. We can do anything with it. So let's do another number. Let's do a bigger number. Let's do a bigger number. Well, you know what? Let's do another one, but instead of 99, we're going to do 9 minus 9. Oh my God, what does that mean? Well, it's the same thing. What we're going to do is minus the 9 is equal to minus the 10 plus the 1. But now what's going to happen? We're going to do our two-step equation. How do I know? Because we don't have anything here. So we do 100 and we want to minus the 9. Minus the 9. I'm going to minus the 9 here. I can't do it. So what do? This is where we know this formula, but now we need to use commutative property, which means that I can reverse the 2, right? So I want to do 9 is equal to plus the 1 minus the 10. So before I forget, I'm going to plus the 1, right? I'm going to plus my 1. Now I go to my 10. I need to take away my 10. Can't do it. So now what do? Remember how to minus the 10? Minus the 10 is like the same thing as minus 1. Minus 1 is equal to minus the 10 plus the 9. Again, I'm going to do commutative. So 9 plus the 9 minus the 10. Why? So then I can say plus the 9 and I take away the 10. I'm going to take away the 10. So my answer is left with 91. So this was a two-step equation because we did this one and then we did this one. Oh, my answer is 91. Hey, Kaylee, did you wait? Weren't you just here? So, does that make sense? Are we okay? We're all right? So that's the thing about Abacus. I mean, everything is logical. There is not one question that I have found that I could not do with the four formulas that we know. So again, if you look, this is just a plus 10. This is just making of a 10. It's just how do they all fit in like Tetris? It's like Tetris. How do they all fit in? It's like, it's not a jigsaw puzzle, because jigsaw puzzle means that they're predefined. It's like Tetris, because you're trying to fit your shape into the thing. Yeah, right. I mean, we can take it one step further. We can do 999. Can you do multiplication again? Yeah, let's do multiplication. We can do multiplication. So, um, excuse me. Okay, multiplication. Here is some multiplication questions. We'll do this one. Okay, we got it. Got it. Okay, so we're gonna do 45 times that by 6. 45 times 6. Is that crazy? That's not crazy. What's gonna happen? What we got to do is we got to count our digits. So in multiplication, we need to know where to put our answer, because on the abacus, it will help us track our answer. What does that mean? Well, we got to figure out how many digits we have. We have 1, 2, 3. We have 3 digits. To have 3 digits means we're going to start at our hundreds. 1, 2, 3. Because of my ones is this one. So I just need to count 3. Okay. So I got my 3. Now, if you notice, yes. If you notice, we are going to do outside first. We do 6 times 4 equals to 24. So I'm going to add 20. Thank you so much for the feed chocolate. That's so strange. Thank you, Beal. So we're going to do 24. Add 20 and I add 4. Right? 24. Notice I don't need to say 240. I don't need to say that. I just need to say 24 because I know my multiplication facts, and I know 6 times 4. I don't know 6 times 40. That's not on the chart. Abacus makes manageable chunks. Manageable. So manageable means this. We don't do this. That's not what we do. So what's next? Well, I'm here. 5 times 6. Thank you. I look forward to your next live session. Good night. Good night, Trey. So after 5 times 6 is 30. Now what happens? Well, I need to add 3. I can't add 3. How do I add 3? Thank you for the heart finger, Trey. How do you add 3 to this 4? How do we add 3? Do you remember? We need to utilize our 5. Yes, thank you, Javi. So what we're going to do is to add the 5, right? Oh, hold please. Yes, Lofty, that's what it is. It is. Oh, excuse me. Okay. We're going to plus the 3. Plus 3 is equal to plus the 5 minus 2. So I'm going to plus the 5. I'm going to take away the 2. My answer is, what's my answer? What's my answer? I got to put it here. Yeah, what's my answer? Oh, that's too many zeros. Because this is my ones. My ones is right here. 270. Yes. Thank you, Bill. Yep. Yep. User. I just see user. I'm sure it's user. Okay. Yes, Lofty. No, you're good. You're good. But it makes sense, right? Because this is my ones. We don't want to have too many zeros. And that was the thing, right? We want to track it. So when we track it, right? Now, if you notice, we can do more. But then if you notice, we can do here. We do, I don't know, 3, 4, 6 times that by 7, 3. Same thing, but it's not FOIL, right? What is it? First, out, inner, left? I don't know. We don't do it that way. We do, what Abacus does is we do left first. We do the outside first, and then we do the next number, and then we do the next number. So again, where's our starting point? Our starting point is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 7 times 3 is equal to 21. So I add my 20, I add my 1. 7 times 4 is 28. I add 20, I add 8, and then I'm here. 7 times 6 is 42. 42. I add 4, and then I add 2. I add 4. How do I add 4? I cannot add 4 to this. What do I do? How do I add 4? Plus the 4 is equal to plus the 10 minus 6. How do I know I'm going to use that? Because I don't have a 5 to add. I'm already using a 5. I can't have a 5 to add. So what do? I have to plus the 10 minus the 6. And then plus the 2. So I'm done with the 7. I got to reassess. Does that make sense? I'm going to reassess. To reassess, I just need to count. What's left? 1, 2, 3, 4. 1, 2, 3, 4. So then, maybe I should change color. So then, I'm over here. 1, 2, 3, 4. 3 times 3 is 9. 9 is a single digit. I go back one column and I add the 9. How do I add the 9? I don't have enough beads to add the 9. This is where it gets a little tricky, right? So 9 is equal to plus the 10 minus 1. I'm going to plus the 10 minus the 1. I'm going to minus the 1 so I don't forget. I'm going to minus the 1. I need to plus the 10. How do I add the 10? I cannot add the 10. I know plus 4 is equal to plus the 5 minus 1. Plus the 5 minus the 1. Okay? So now I'm here. 3 times 4 is 12. I'm here. Plus the 1, plus the 2. And then 3 times 6 is 18. Plus the 1, plus the 8. Plus the 1, plus the 5 minus 4, and then plus the 8. Wow. So what is my answer? My answer, what's my answer? Hopefully that's correct. Hey, Earl. Welcome back. Whoop. Wow, 7,000 likes. Thank you, guys. I appreciate that. So, what's my answer? Hopefully that's correct. Been moving around a little bit. 28,258. Yes, exactly. That's what it is. 28, comma, 2, 5, 8. Yep. See? But see, the thing is, it's exactly the same. Whatever we did here, we do here. We're just building on top of each other. And we just keep doing it again and again and again and again. But see, the thing is, what I'm saying here, notice these are manageable chunks. In mainstream math, right, they do 70 times 300. And I'm like, what the heck? That's a lot of numbers. And then they do another one, 70 times 40, and then 70 times 6. And then they do it again for this. 3 times 300, 3 times 40, and then 3 times 6. 3 times 6. Which, it makes sense they do it this way because they write it out. But in Abacus, we don't need to write it out. That's why we have the tool. Use the tool for what it does. Use a hammer for what it does. Use the screwdriver for what it does. Use the Abacus for what it does. And what it does is it helps you track the numbers. Abacus helps you track the numbers. That's it. Cool? I get on a little tangents. Ah, thank you so much, Bill. Can you show an example with decimals? Please. Yes. That would be too easy. You know why? Because it's just another column. That's all it is. La la la. Let's see. Here's an example. So the first thing we're going to do, and it's exactly the same. It's exactly the same. It's just now we're with decimals. So here, let me do this one. 41. Oh, sorry. Hey, Evelyn. So 41. Oh, where am I? 41.46. And then add 20.35. Same thing. It just lines up. So we do 41, 41, 46. And then plus 20, right? Plus 20, plus 2. There's not enough to plus the 2. So what do? Plus 2 is equal to plus the 5 minus 3. Plus the 5 minus 3. 20 is 0. This one is 3, right? Plus 3 is equal to plus the 5 minus 2. So plus the 5 minus 2. And then plus 5. Well, how do I do plus 5? Plus 5 is equal to plus the 10 minus 5. So I plus the 10 and I take away the 5. So then my answer is 61.81. Easy peasy. Right, right. But see, that's the thing. We think that the decimals is something different, but it's not. It's a little different when we do multiplication. So what does that mean? Well, let's do multiplication. So we do 41 point times that by 35, right? So it's the same thing. We only count these two. So we're in 2 digits. Is that right? I think so. 1, 2. So we do it again. 4 times 3 is equal to 12. I add my 1, I add my 2. And then I do it again. 4 times 3 is equal to 3. 3 is a single digit. I go back one column, I add 3. Okay, I'm done with this. So I got to start at the 1 because I only have 1 left. So 5 times 4 is equal to 20. So I add the 2 and I add 0. And then 5 times 1 is equal to 5. So I add 5. 5 is a single digit. I add my 5. So then my answer, I should have changed colors. I'm sorry. So my answer is 1, 4. My decimal is here. 0.35. Right? So it doesn't, we don't need to line it up because the abacus helps track it. We just need to be able to count. Thank you for the popular vote and the heart me. Fart. Yeah. Does that make sense, Javi? So when we do it, we have to make sure. That's why we have to make sure where we put our answers. Where we put our answers is how we know where we're going to have the decimal. If you mistaken your columns, sorry, I don't know what you mean by joining. I don't know what that means. And I'm not sure. You've answered both the questions that I had. Oh, okay, great. Yeah. I requested to join. For what? What are you joining? I'm just talking about math. What question would you have? The live. Okay. What, like a battle? A what? The live a what? I'm not sure what you mean. I'm so new to this. I'm so sorry. I don't understand what's going on. Okay. So does that make sense? If they put I have many questions. Okay. Or just their voice. Can you use this as a calculator for simple multiplications like 8 times 3? No. You have to know your multiplication facts. You need to know your multiplication facts. All right. Well, I don't know. Your username kind of a little bit. Uh-oh. That's not good. Proper username. Trust the process. What do you guys think? Am I gonna should I do it? All right. What do you think? All right. All right. All right. No go. I don't know. Yeah, see, I don't know. Because your username is not very convincing. You know? I'm sorry. Yeah, me too, right? Sketchy, right? Okay, good. It's not just me. All right. I've been here. I wouldn't. Yeah, okay. You okay? I'm happy you've been here before, but if you have questions, then you can type it in like everybody else. Just saying, because your name is kind of kind of sketchy. Okay, so you know the one thing though, Javi, division would be division would be kind of interesting. Okay, um, so yeah, user I would do is the one thing would be you have to know your multiplication facts. Oh, however, I'm not sure if you know. I didn't know until I started doing this, but you could start talking about additive addition, cumulative addition. So let's say we had 8 times 3, but instead of doing 8 times 3, what you could do is 8 plus 8 plus 8. You could do that. So then on the abacus, and this is how I got my kids to learn their multiplication because they got tired of adding. So they did 8. They did 8, and I need to add another 8. To add another 8, I need to plus the 10 minus the 2. So I plus the 10 minus the 2. So my answer is 16, right? So then they do it again. I need to add another 8. Well, this is why they get this. This is how they strengthen their stuff. So when they strengthen their information, right? They strengthen their number facts. It's plus the 10. 8 is equal to plus the 10 minus the 2. So I'm going to plus the 10. I need to take away the 2. Can't take away the 2. So what do? Minus the 2 is equal to minus the 5 plus the 3. So I minus the 5 plus the 3. So my answer is 24. So when they see this more often, what would happen is they're going to start slotting hijinks USA, please. Okay. So what's going to happen is they're going to start slotting, like they're going to remember certain words. So when they learn certain words, okay, hijinks USA is still a very questionable username. Okay, so what I'm saying here is, so then the answer is 24. So what if they remember what like 8 times 5 is, right? So if they know what 8 times 5 is, it's 40. But like, okay, if I forget how to do 8 times 6, 8 times 6, I know would be 48. They switched their username. I'm good, I promise. I don't know, dude. Did that? I don't know. I don't know. None of the questions you have asked have I not answered, except for requesting to come on to my live. So, oh, I'm a good student. You always block them if they act out. Can you always block them if they act out? Yeah, but I don't want to be traumatized. I've had a couple of spammers and I've blocked them out. True, you can block me if I'm bad. You have to give me a valid question. If you have a lot of questions, I mean, everybody else has been commenting. Okay, sorry. So, going back to this. So, they would start to anchor their concepts, right? So then they would understand that, oh, if I need to do what 8 times 4 is, I know I need to subtract 8. So this is how you get number flexibility, if that makes sense. So what happens is, and then and that's how sometimes I read it. So like sometimes if I need to do 8 times 7 and I'm like I don't remember what 8 times 7 is, what I'll do is I'll add 8 to my 48 because I remember that, if that makes sense. So then here is 8 times 7 is equal to 56. So then they can build upon each other. But this is how you get a more flexibility, and that's what I would do. Okay, what I know is that the dots are kind of like placeholders. Once you reach a maximum amount, you move to the next. The dots are kind of like placeholders. The dots is not a placeholder. The dots is the indicator that Lofty, good night. Okay, yeah. Have a good night, Lofty. Hi, Jinx. Okay, good. I'm happy. I'm happy you're creating a proper question. So this is the dot. These dots is an indicator. This is a label. So this would be my ones. So I have my ones, my tens, my thousands, my 10,000s, and my thousands and my 10,000s. So that sounds familiar. Yeah, yeah. So if I had my indicator, this would be my ones. So I have my ones, my tens, my thousands, my hundreds, my thousands, and my 10,000s. So, and if you run out of room, that means you got to get a bigger abacus. And this is a 7-column abacus, and this is a 13-column abacus. So with my 13-column abacus, I can have more numbers. If I start in the middle, I can do it. I have my ones, my tens, my hundreds, my thousands, my 10,000s, my 100,000s, and then my millions. If this is not big enough, then you go all the way to here. Hi, Hazel. Right? Then you can start this to your ones place. So your ones, every digit has a separator. So I have my ones, my thousands, my millions, excuse me, my billions, and my trillions. So, all right. Do we have any more questions about multiplication and division? Oh, but did that make sense with the additive, cum, cumulative addition? That's what this is. And so that was the one thing is like I never learned it this way, but then when I was trying to explain it to other kids, I was like, "Oh my god, this makes it so much it makes a lot of sense to me." And so now what I do is I teach the kids this way because although it takes them time to memorize, at least they goes through the motion. So there was this one student I had, and that's what he did, and that's how I got it from him, because he didn't know his 4 times table or whatever, so he just started doing it on the abacus. 4 plus 4 plus 4, that's 12, and then plus 4 again, that's 16, and then plus 4 again is 20. right? So he didn't know his 4 times table, but he used the abacus to help him calculate, help him add. Hey, Dylan, welcome. So, all right. If there's no other questions, I am going to sign off. Big NCM. Interesting. Um, yeah. Is there any more questions about abacus? I don't know what that seal means. That's all like new stuff. All right. Thank you, user. I appreciate the comments and the support. I appreciate you. How often do you go live? I go live pretty often. I try to go twice, depending on I try to go twice or 3 times a day. Um, yeah, because I think it really helps me solidify what I'm trying to do. So there's like some questions, and so I have like students and stuff, and so and the parents are learning to do abacus, and there's some questions are a little bit. It takes a little time for me to do it. It never sleeps, Beal. I'm sure I'll have some once I get an abacus. Yeah, yeah. Yeah, let me know. I'm still building out my. I think I'm going to publish my pages that I have, and then I'm going to publish all the pages I have that I've built, so I have all my mazes. And then after I have my mazes, um, here let me take you on a field trip. So this is what I got so far. So now I'm doing the 3-digit mazes, which is kind of cool. I like it. Right now I'm doing answers, and then and then so what I'm going to do is I'm going to publish out my 2-digit one. So my 2-digit one is this one. So what I did is um what I did is I added, do your markers have smells? Yes, they do. Um so what I did is I have my big brain notes, and here I start to talk about how to use it, and then here I made it hollow. I made it an outline. The reason why I made an outline because I wanted the user to color in the beads. So this is about how to recognize what the beads are, and then this is what the abacus looks like, what the number looks like, and what it looks like as a drawing. And then after that, it goes into how to read the abacus. Again, it goes from 0 to 9, and then after that, we go into the double digits. And after double digits, I think I'm going to publish this out. And then this would be the place values. Here, I added the abacus. All you got to do is just break it up. This would be 3, and then this would be ones. And then after that would be the mazes. Yeah, after that would be all the maze. And then that's it. And then there's answers to the maze. I think I'm going to publish this out. I think this is ready to be published out. It will be a downloadable first, and then when I have enough, I will make it into a book. I think so. That's what's going to happen. That's what I'm going to do probably tomorrow. Yeah. So, yes, I do play chess, but my kid's better. When does this translate to real world? Oh, thank you, Bill. When does it translate to real world? It if you're working with if you're working with arithmetic, it will translate to anything. I don't know what ELO is. Okay, okay, hijinks, I'm gonna have to ban you if you're gonna continue to digress. But you know what? If anything, I'm going to sign off. But that's the thing. So what I'm going to do is I'm going to publish that out to my website and then have that out. It's just, a bunch of things. Just everything's kind of everything's coming to fruition. I do appreciate everybody commenting and providing comments and understanding where everything is. So, um okay. Yeah, see, hijinks, you only have 14 followers and 7 following. I'm not sure about you. All right. If anybody has any other questions, I will sign off. All right. If anything, let's see. Have a good night. Yeah, have a good night. Thank you. You too, Javi. I'll see you guys later. I'll see you guys in my next live. And then Steph, good luck on the fractions. Thank you for the rose, Steph. Okay. Um, okay. Have a good night, everybody. Thank you, guys. I will see you guys in my next live. Bye. And now. Sloth Master 420. My God. This account's private. I see it didn't work. It did not work. Oh. End stream.